Welcome to the IT Fundamentals Training Series. My name is Mark Haupt. I'm your host, and today we're going back in history with a little bit of a history lesson. Also, we're going to take a question from one of our students. So join me as we go into episode 34, chapter 4, Operating System Fundamentals. Welcome back to IT Fundamentals Training Series. This is your host, Mark Haupt, and today we're going to talk about the operating system fundamentals. And really, we're going to go on a little bit of a computer history lesson today. So if you are in a history class or need history credit, today could be just that for you. But before we get there with that, I want to talk about a couple of questions that have been presented by one of our listeners. To be kind of funny, but we'll kind of take a look at this. So you'll have to go back and take a look at these questions. But if you go back to chapter 2, question 15, in the back of the chapter, the recap questions, it was put to me as just like this. That question talks about which of the following does not provide digital video output. Okay, we all know that the answer is VGA because that's an analog communication or an analog process in there. But the question that was actually posed to that is a very interesting one that the book does not cover. And it says, I don't remember reading a lot about digital and analog. So is analog like AC, alternate current, and digital is like DC or direct current, if it were in electrical terms? So the question wants us to know the digital side is the newer and more preferred option, or is there something else? So let's tackle these backwards going up. So yes, the question and the training wants you to know that digital is the newer and the preferred option. Every single option that was presented to you in the book prior to that question in chapter 2 was digital related in some way, shape, or form, except for the VGA option. So the answer is VGA. The book wants you to understand that we are in a digital society. Now, the real question, though, the root of the question is, what is the difference between the analog and the digital? And here's what it is. I don't look at it as the question presented, is it like AC and DC power? I don't look at it that way because it's a little bit different than that. An analog scenario is a modulated signal. So on the electrical wire, modulated signal means that you have highs and lows in the actual signal itself, in the frequency of the signal that results in that transmission of the communication into the monitor that displays the information on your monitor. So it's a modulated signal, if you will. And if you can go look up modulated signals from there. But the digital side is more of a ones and zeros, a binary signal that's going across a steady modulated electrical signal. So that's really the difference between the two, is that the digital side is ones and zeros, just like any other piece of software or the BIOS or other functions that we've talked about with the computer. It's really kind of turned the signal into, or the communication of the medium, or communication of, not the medium, the communication of the information across the medium, which is the wire. So the wire is standard. It's got it's an electrical current going across there in order to transmit it. But the ones and the zeros inside of that scenario are what results in the monitor converting or bringing up the information, versus an analog, which is actually a modulated signal. I know that's a little confusing. Here's the bottom line. Just know that VGA is analog and digital is the way to go right now with everything. All right. And then, a couple of, question 7 for chapter 3. That was another question that came in. It says, it's kind of confusing. Settings will rotate 90 degrees now. My guess is it's an older type of scenario. And that's exactly right. You got to remember, this book and the information in the book, it gets dated very quickly because systems update very quickly. So what we're talking about here is we're talking about the mobile device and the fact that you can rotate the device and look at it in a horizontal versus a vertical or portrait type of view. And so question 7 is regarding that. In fact, let's just switch over to question 7. It says, Francis is trying to change the settings on his iPhone. He opens the settings app to see them better. He turns his phone 90 degrees, but nothing happens. What is the most likely cause? The gyroscope is broken. The settings app does not support rotation. He needs to enable app rotation in settings first. He needs to turn off the device and turn it back on to reset the rotation feature. Okay. So I'm going to give you a couple of seconds, honestly, when I turn to the back of the book, just to verify my answer. But before I go and cheat by looking at the back of the book, I think it's he needs to enable app rotation in settings first, which may be part of the confusion because I know that's how I do it on my iPhone. But let's go back and let's see what they say is the question. So chapter 3, question 7, it says B, not all apps support rotation, and settings is one of them. The app needs to be specifically programmed to support rotation. So see there, I was wrong. You know what, now that they say that, I do know one app that really doesn't support rotation, and that is, I mean, you can rotate it, but it doesn't work very well, and that is my Credit Karma app on my iPad right now. In fact, I'm just looking at it here, and it really doesn't support rotation very well at all. So it actually is B, the app. The settings app does not support rotation. See there, I would have gotten it wrong too. So, but that's not covered very well in the book, or at least it is, but you kind of skip over it because that's one of those things you already, kind of figure or kind of know. All right, well, let's pick up with our history lesson in chapter 4. We're going to pick up on page 175 and kind of look at the history of operating system fundamentals. Now, you don't need to know a lot of this information for the test. So this is more for your knowledge. And by the way, I want to say congratulations to somebody kind of zoomed ahead of us. David, you know who you are if you're listening. He studied IT fundamentals for about a week or two at our recommendation, and started on with this process, studied it, and went and took the test and passed it on his first time. So we have someone that we know who passed ITF Plus right away, within a week or two of studying. So you could zoom ahead if you want, but hey, this is a paced course. All right, so operating system fundamentals. So from a history perspective, I think one of the things that I want to point out, if I had a highlighter, electronic highlighter here, I would point out in this book is the first sentence underneath the operating system fundamentals section that says, it's important to take one step further back and talk about software in general. In computing, there are 3 major classifications of software that you'll be dealing with. It's the operating system, the applications, and the drivers. I would almost argue that there's a 4th as well, but they probably fall under the application section. But there are some software out there that's considered both an operating system as well as an application. In particular, something like Microsoft SQL database operates both as a database, which would be an application, as well as when you lay it down, you actually lay it down as a whole with the operating system. You don't necessarily, although you can, you don't necessarily have to lay down that product on top of a Microsoft server to begin with. So there's three from their perspective, there are 3 operating systems, applications, and drivers. And then it goes on to talk about the operating system. And what operating systems do is again, very well written here, is it provides a consistent environment for other software to execute commands. So basically, the way I look at it is operating systems are your basic functionality, and then you layer other things on top of it in order to make it more functional. All right. So let's take a step back ourselves and think about this. Remember how we talked about BIOS way back in chapter 1, or early on in chapter 1, we talked about the basic input output system, or BIOS. That is a very basic OS. It gets the computer up and running, gets the components talking to one another, and then it stops there and allows you to lay something else on top of it. Based upon that piece of information, you could almost argue that Windows Server or Windows Workstation itself is an application on top of BIOS and not an operating system. That's just a simplistic argument on that. But because Windows or Linux or Apple iOS all have ways to interconnect the very basics of the computer together, it is considered that operating system. All right. So the operating system is kind of the focal point. Your hard drives talk to it, your processors, your devices, memory, input, output. That's in figure 4.1. And how that interacts with the different pieces of hardware. Now, an application is a piece of software that's used to accomplish a specific or particular task. So, for example, we talked about Microsoft SQL database. Its specific task is as a database. And so it will function as that, and that's the only thing it's going to do. You have Internet Information Server or other types of web servers like Tomcat, for example. Their whole function is to do nothing but be a web server to serve those pieces of software up across the internet to you as the end user and looking at the browser. So different pieces like that are the application. So you can think of it, the operating system is at the layer where it's the command and control function. The application is a job specific or subject matter expert function that goes on top of that. And then you get to that driver aspect, which is an extremely specific application written for the purpose of instruction. So the driver, for example, will tell the operating system how to communicate with your hard drive or how to communicate with your printer or your specific type of monitor. And in the software world, we call that API, or the interfaces between one application and another that allows them to transfer data and communicate with one another through the application function. So the driver is key for communication between as a specific type of application. All right, going on to the history part. Way back in 1930 something, computers were not electronic devices. In fact, if you go watch a couple of movies, one in particular would be in relation to space programs, those types of movies. A lot of times early space programs would have computers, and those computers was a job role that an individual human did. Okay. And so back in the 1930s and 1940s in particular, even beyond that, a computer was a human's job. And that was then taken over in the 1940s and 1950s in many cases by the hardware that was doing nothing more than calculations, mathematical calculations that the humans were doing. So a computer was a mathematician, you can think of it that way. And they would sit there and they would do math and numbers. They would do calculus and all sorts of things. In the space program, they would try and figure out how to get orbits going and how to get extra orbit, get out of orbit to go to the moon and come back, and things along those types of things. So they were calculating different kinds of mathematical computations and theory, and they transferred that over to the computer. That's the basic first thing that occurred in roughly the 1940s. Now, the book says in 1946, but I can tell you from my own experience that as early as 1942, even in the 1930s, there were computing systems. There were how can I say this? There were devices, if you will, that took up entire rooms that would do computing and be a computer. Okay, especially during World War II when we were dealing with radar and we were dealing with encryption and decrypting things and signals intelligence or electronic intelligence. A lot of those functions were taken over by computing devices. There's a number of movies about that as well that you can take a look at. All right. So somewhere in the mid 1940 or mid 1950s is when people kind of settled down and said, "Hey, we need to have computers do a little bit more." So we started with Fortran and other types of programming device or programming functions where the computers were doing more than just mathematical computations. One of the things to remember about these computers, we have these little bitty laptops, or quite frankly, even this, the iPhone right now is a computer that is more powerful than the entire computer system that went to the moon on Apollo. On the Apollo space missions was more powerful that iPad or that iPhone was than the entire thing that was up there. But back in the day, a computer would fill an entire room. And here it is. There's a picture in figure 4.2, and there's also a little description up here about the ENIAC, talking about how huge it was at 18,000 vacuum tubes. And I know most of you folks don't know what vacuum tubes are, but they were little glass tubes that used to power or used to present TVs and television signals and all sorts of stuff along those lines. But those 18,000 vacuum tubes, along with 70,000 resistors and 10,000 capacitors, it was 8 feet tall, 3 feet thick, and 100 feet long, weighing an impressive 27 tons. And I can tell you that was not the largest computer. They were much larger than that, especially as they went further on. I've seen some of these computers or the remnants of them, and trust me, they are huge. The other important thing about these old computers was they had no programming inside of them. They had to have an operator that actually, if you remember some of the movies, the old movies, where the telephone operator would pull a plug out and patch it into another hole. And that's how you got someone calling from one place to another. It wasn't you just dialed numbers. You actually got an operator and they were plugging those things. It's the same thing on the computer. You had to take one patch cord out of one patch panel and put it into another in order for the signal to transmit and do what it was supposed to be doing. So those are some really challenging times, but very effective times. You got to think about it. These computers are what took us to the moon. These computers are what originally took us to space. These computers are the ones that built the first jets that went over the speed of sound. They developed rockets. They developed massive encryption systems. They built the atom bomb. They helped the Manhattan Project build the atom bomb, and these computers did a tremendous amount of work in that process, or in their lifespan, that previously nothing like this could be achieved. So we owe a lot to those operators that sat there and moved one plug to the other, and so on and so forth. All right. So, as we all know that, the computer really started to take off in the 1970s, and in particular the 1980s, when the operating systems became functional, where you can do drawings, where you can do word processing and things along those lines. And we had and gaming, and we had new computers that were now starting to get into an individual's home. And that was really the impetus behind Apple computers, was to try and get a computer in people's homes in order to proliferate the use of computers. And certainly enough, although Apple doesn't have the largest market share right now in regards to computers, they certainly do on phones, they certainly do on tablets. The Apple effort to miniaturize the computer and get it out into the world, as well as IBM. We can't forget IBM. I remember walking into Sears and Roebuck in the late 1980s and going, "Oh, I'd love to have that IBM computer." And compared to today's computers, it was a joke. It was, again, less powerful than my iPhone here. But I would see those types of things and I would look at them, go, "Oh, look at the massive thing. Look at all those things that we could do. I could create databases and this and that." And sure enough, here I am in the business now because of that. But I will tell you that, I did get some experience in making a turtle cross the screen, and I got some experience with that programming there, as well as creating the databases. Playing games were important back then because they got you used to typing, and they got you used to playing with a mouse and learning how to use a mouse, and so on and so forth. So the 1980s in particular were a massive boom in the use of personal computers. And that is your history lesson for today. I mean, the 1990s brought the internet, and we all know about that and where we're at with that today. And the 2000s brought the tablets and the cell phones that we call smartphones, and we are all playing with those today. So that's your history lesson on computers. Again, I hope you reach out and communicate with me. We had a couple of folks communicate with us and got some answers back to them very quickly about those questions we just talked about. I really texted them back the answers days ago, but just wanted to make sure that everybody who may be struggling with those same questions were able to have those questions as answered for them as well. So get a hold of me, mhaupt@commonsensesecurity.net. Keep plugging away on your book. Again, we had somebody jump ahead and really take off with this and already certified. So congratulations to you, David. And for the rest of you, don't feel bad. This is how you learn, slowly and surely. But this is a great opportunity for you to get that IT fundamental certification. Next time, we're going to dive in a little bit deeper on the basic functions of operating systems and talk about the kernel and the version, the source, and all that kind of jazz. And that's where we really get down into the nitty gritty on operating systems. So look forward to talking to you. Give me a holler. For now, keep plugging away on ITF Fundamentals Plus.